Today, I am very excited to have the opportunity to share with you some recent advances in the field of additive manufacturing, more commonly referred to as 3D printing. 3D printing is a unique form of manufacturing that, unlike traditional methods, divides the desired object into a series of microscopic planes and adds each layer in a sequence until there is a final product. The best way to picture this would be to imagine 2D printing hundreds and hundreds of pages of paper, then removing anything on the paper that wasn't touched by ink. By adding material in this layer-by-layer fashion, it enables us to manufacture geometric shapes that are impossible by traditional methods. It also allows us to stop in the middle of a manufacturing process and integrate other technologies into the very fabric of the material itself. The field of medicine has proven to benefit enormously from this technology, especially in respect to innovations in prosthetics. Manufacturing with 3D printers permits us to cheaply assemble a large quantity of prosthetics in a very short period of time. They are so exciting because they are uniquely designed for an individual's comfort and support, and a number of capabilities that have only become possible in recent years. The history of prosthetics has been a more or less stagnant one for centuries, as patches and peg legs have been the standard model for far too long. The earliest known prosthetic dates back to 300 BC. It seemed to have been made for below-the-knee amputee, made of bronze, iron, and a wooden core. Then, the Dark Ages came about with little to no advancements other than the hook hand and the peg leg, but these were primarily restricted to the wealthy. Finally, new light broke through in the 1500s with advancements in both hand and leg prosthetics. For example, a new iron hand was made, which had the ability to be manipulated and moved by relaxing a series of releases and springs while being suspended with leather straps. Skipping ahead to modern day, more expensive prosthetics have been made of plastic polymers that are poured into the negative mold of the patient's amputation. For those who can't afford this, mass-produced prosthetics are also available, but are often accompanied by a number of complications. Currently, we have successfully started the transition from mass-produced and expensive prosthetics made in a time-consuming manner to more affordable and individually unique prosthetics constructed by 3D printers. Furthermore, the cost of manufacturing is significantly reduced by replacing negative molds with 3D printers, opening up this technology to a whole new population of people. Throughout history, prosthetics were only affordable for the rich and were only sometimes provided to men injured in war. The accessibility of prosthetics has been a common problem that hasn't had much agency for change until now. Even in modern times, your typical prosthetic hand costs around $11,000, and that's excluding the hospital fees. With the help of 3D printing, a simplistic yet highly functional hand costs only between $20 and $50, and there are plenty of videos online to aid in their assembly. The ease of using 3D printers has increased their popularity and subsequently their availability in a number of locations, such as schools. During the decade since 3D printers became mainstream, we have managed to significantly reduce the cost of an average prosthetic and increase their accessibility to the general public, forever altering the lives of those who couldn't afford it prior. Now, you may be asking yourselves, what makes 3D printing so different from traditional methods? Well, the answer is CAD, Computer Aided Design Software. CAD replaces the need to make a negative mold of the desired limb by scanning the object and breaking it down by microscopic planes, just like the 3D printer does. In doing so, the minor variations of each unique patient are identified, and the doctor can adjust the prosthetic for maximal comfort of each individual. Furthermore, the chance of human error is drastically reduced without requiring a prosthetic technician to make the negative molds. This process is actually so simple that an individual with little to no experience using a 3D printer was able to print a hand for a 13-year-old boy named Dawson Riverson who was born with missing digits on his left hand. Dawson's new robotic prosthetic is capable of simple grasping motions by flexing his wrist back and forth. This opens up a world of possibilities previously inaccessible to him and every other child with similar afflictions. He can now ride a bike and be a goalie for his soccer team, increasing the quality of life immeasurably. This application of 3D printing will surely last and continue to be improved upon, because prior to this, prosthetics were very inaccessible and unnecessarily expensive for a child who would soon outgrow the limb. Now, Dawson's prosthetic may be revolutionary in respect to product availability, especially among younger age groups. However, the design is very rudimentary when compared to anything produced by professionals. With the help of CAD software, we now have effortlessly integrated other technologies into the material of the prosthetic, giving them an entirely new set of capabilities. Now, the portion of the prosthetic that connects to the amputated appendage is known as a socket. Accumulation of sweat in this location is fairly common and can lead to rashes, infections, and even outside growths detrimental to the patient's health. This is increasingly prevalent in leg prosthetics compared to arms due to their increased need for strength, endurance, and stability. The additive manufacturing process can be temporarily stalled so that fixtures such as moisture sensors, pressure gauges, and biocides can all be implemented inside the prosthetic. This wouldn't be possible by the traditional means of negative mold construction. This mode of manufacturing exponentially increases the sophistication and capabilities of any type of prosthetic one could imagine. Even wings are included in the types of limbs that can be benefited from this 3D technology. 3D printing has enabled scientists at Stanford University to create a prosthetic wing for birds and bats capable of closing upon impact to avoid damage and to prevent the animal from spinning out of control. Additive manufacturing enabled them to create an interior structure connecting from one tip of the wing to the other that cannot be done by means of traditional robotic assembly. These wings have effectively increased the survival rate of any bats and birds on the path of rehabilitation into the wild, and proves that the range of additive manufacturing is always expanding. The future of 3D printing prosthetics is limitless. Currently, the latest projects include developing new software that has the ability to 3D print prosthetics for people who have lost full arm or legs and require special movement in order to perform daily activities. Progress has also been made in the rejuvenation of patients' nervous systems to attempt to use them as a stimulus for prosthetic movement. With innovation growing every day, we hold the power to affect millions of individuals through a simple device. I would now like to end this talk with a story about a young woman named Amanda Boxtel. She has a spinal injury that has pronounced her wheelchaired for life. Amanda is one of 10 test pilots who assisted in the design and testing processes of 3D printed exoskeleton devices. Using data obtained from a full body scan, custom parts were printed to perfectly fit Amanda's body. With the addition of bionic technology, she now has the capability she once never used to have in order to walk using her exoskeleton suit. The quality of her life has since improved significantly with the affordability and advanced technology of additive manufacturing. Stories like Amanda's is the reason why research is such an exhilarating field to be in. 3D printing prosthetics is the next stepping stone of the medical industry, and I look forward to seeing this progress for more comfortable, affordable, and sophisticated models. Thank you.